Hello, good day. For today's lesson is about representation of rational functions. The rational function is a function of the form f of x equals to p of x over q of x, where p of x and q of x are polynomial functions, and q of x is not the zero polynomial. The domain of f of x is all values of x where q of x is not equals to 0. So we take note, our q of x is not equals to 0. Why? Because once this is the value of this one will become 0, the function will become undefined. Okay, to better understand this one, let us take the first example. Consider a 100-meter track used for foot race. Represent the speed of a runner as a function of time it takes to run 100 meters in the track. Since the speed of the runner depends on the time it takes to run 100 meters, we can represent speed as a function of time. So let us assume that x is representing time and the function s of x represents speed. So based on this problem, we can make our function as s of x equals to 100 over x, where 100 referring to the distance of the track. So in order to determine the behavior of the function as the variable x changes, we will make a table of values containing the runtime period from 10 to 20 seconds. Okay, from that, so since we have already the assumed value of our x or the runtime, we will now compute the value of our function by using this function formula. Okay, by substitution, so we have 100, the value of x is 10, that is equals to 10. When the value of x is 12, then the value of our function is the value of our function is 8.33. Okay, then when the value of our x is 14, then the value of our function is 7.14. Okay, so that is how to find the value of our function using the given value of our x, our runtime period. So you have to do the same to answer the rest of this value of our function. So for 16 we have 6.25, and for 18 we have 5.56, and 20 is 5. Okay, those are all the value of our function based on the assumed value of our x, our runtime period. So after that, in order to determine if we're going to plot that one in our Cartesian plane, whether it follows the smooth curve or straight line, so we have to graph that one in the Cartesian plane. Okay, so we have here on the left side our table of values, and here is our Cartesian plane. We will plot that one in our Cartesian plane. So the first coordinate is 10 for x and 10 for s of x. So that point can be found here, this point. Then the second one is 12 and 8.33, so somewhere here. Then 14 and 7.14, so something here. Then 16, 6.25, So something here. So 18 is 5.56, something here, somewhere here. Then the last one is 20 and 5, middle of 4 and 6. So that is those are all the points from this table. So if we're going to connect that one, as you can see that the points are not collinear, but rather it follows a smooth curve. Okay, that is how to uh, graph graph the given function using the table of values. Okay, to understand it more, let us take the second example. The second example represent the function given by f of x. F of x equals to x minus 1 over x plus 1 using a table of values and plot a graph of a function by connecting points. So these are our tasks now. No, we're going to make a table of values from this function and plot those points in the Cartesian plane. Okay, so in this case, we have first build our table of values. Our table of values, let us assume number from 10, negative 10 up to positive 10. Okay, so if those are the assume values for x, then what's the value of our function in each of those assumed number or assumed value of x? Okay, the same procedure with the first given or first example, we have to substitute x with the value of x in our table. So here we have 10 minus 1, then negative 10 plus 1. The result for that is this one, negative 10 and negative 1, that is negative 11, all over negative 10 plus 1, that is negative 9. So the answer for that is 1.22. So 1.22 is the value of our function when the value of our x is negative 10. How about when the x is negative 8? So just the same, no? You have to write the value of x, which is negative 8, then copy negative 1, then over negative 8 plus 1. By simplification, we have 9 over 9 over negative 7. Okay, so uh, the result is 1.29. Okay, so that is how to solve for the value of function using the value of given using the assumed value of our x. So you can take the value of this function using this x with this process. Okay, when x is negative 6, the value is 1.4. When x is negative 4, the value is 1.67. When x is negative 2, then the value is 3. When the value of x is 0, then the value of x is negative 1. For 2, we have 0.33. For 4, we have 0.6. And 6, we have 0.71. 8 is 0.78. And the last one, 10, is 8.82. So after that one, in order to uh, determine if those values, if we plot it in a Cartesian plane, whether it follows the smooth curve or not, then we can conclude that by once we see the graph of those points. Okay, so in our left side we have the table of values. So all you have to do is to plot all these values of x and the function to the graph. Okay, the first one is negative 10 and positive 1.2. So positive 10, that is, and 1.2 something here. Okay, positive 10, then 1.2 somewhere here. Then the second one is negative 8. So from here, then something there. Then negative 6 and 1.4 there. Then negative 4 and 1.7, something there. Then negative 2 and 3, somewhere here. Then 0 for x, then negative 1. 0 for x, then negative 1, something here. Then 2, positive 2, then 0.33. Then 4 there, then 0.6. So something like that. Then when x is 6, 0.71. When x is 8, 0.78. When x is 10, 0.82. 0.82. Okay. So those are the points based on this table of values. By connecting that one, we have our graph now. So as you can see, our graph does not follow a smooth curve. There is a broken connection between this point and this point. Why? Why this point is not connected to this point? Okay, let us look at our given. Okay. Let us look at our given. Okay. Our given is f of x equals to x minus 1, then x plus 1. Remember that our denominator is x plus 1. So if we equate that one with 0, let us say x equals to, if we're going to equate that one with 0, 1 plus 1, the value of our x is negative 1. So if the value of x is negative 1, what happened to the function? Diba? This will become undefined. Over negative 1, this will become negative 1 and positive 1. So our denominator is 0. So this will become undefined. So meaning to say that portion is undefined. That's why there is a discontinuity of our graph because of this portion where x equals to negative 1 that could make our function undefined. So always take note that when when the value of our function or our x can make the function undefined, then that portion is the portion where there is a discontinuity of our graph. Okay, so that is one of the part of this topic that should be noted by all of us. That once the value of x can make the function undefined, then there is a barrier or there is a discontinuity of the curve due to this barrier. Okay, now this is a barrier for this curve. Okay, next. The third example represent the rational function f of x equals to x minus 3x minus 10 over x using a table of values. Plot the points given the table of values and sketch the graph by connecting the points. So the same, you have to make a table of values and sketch the graph by connecting the points. Okay, so this is our function. Then still, in order to build our table of values, we have to assume values of x. So for this function, we have to use numbers. We have to assume values from negative 5 to positive 10. Then we will find what is the value of function in its value of x. So the same procedure, we have to substitute these variables with the x values. Okay, let us try the first three. Okay, if we're going to substitute that one, x squared, that is negative 5 squared minus 3 times negative 5 minus 10 over x. So by simplification, we have 25. This is 15. This is minus 10 uh, all over negative 5. Okay, this is 25 plus 15, that is 40 minus 10, that is 30. 30 divided by negative 5, that is negative 6. Negative 6. Okay, so that is how to find it. Let us try to answer when x is negative 4. Okay, by substitution, we have uh, negative 4 square negative 3 times negative 4 minus 10 all over negative 4. Okay, by simplification, we have 16 positive 12 minus 10 all over negative 4. By simplification, we have this one 18 28 minus 10, that is 18 divided by 4, that is negative negative 4.5. Okay, so that is how to find the value of our function given x equals to negative 4. So you have to do the same to the rest of the value of x's to find the value of our function. Okay, for negative 3, we have negative 267. For negative 2, we have 0. Then for negative 1, we have 6. Positive 1, we have negative 12. 2, we have negative 6. 3, we have negative 3.33. And 4, we have 1.5. And for 5, we have 0. Then 6, we have 1.33. 7, we have 2.57. And 8, we have 3.75. 9, we have 4.89. And the last one, 10, which is 6. Okay, those are the value of our function given this value of x. Now, after that, we're going to plot that one in our Cartesian plane. Okay, on the left side, our table of values. Then we are going to plot that one in our Cartesian plane. The first one, we have that one, negative 5 and negative 6. That point can be found here. And 4 and negative 4 and negative 4.5, that point. The next is that point, then that point, negative 2 and 0, that point, then negative 1 and 6, that point, 1 and negative 12, Okay, so somewhere below, no, somewhere below the negative, the positive one here and below. So I did not include that part, this portion, because it is too far from this bottom. So we will just continue to 2 and negative 6. So that's the portion. Then 3, that one. Then 4, negative 1.5, that one. Next is 5 and 0, that portion. 6 and 1.33. Then 7 to 57. Then 8. Okay, and then 9, 489, that one, that portion. Then 10 and 6. Okay, that portion. So if we're going to connect that one, still the graph is not a smooth curve. Okay, so okay, this is now, take note of these points. No, this point and this point. This point is referring to the value in our table of values. This one, this portion, and this portion. So remember that when the value of our function becomes 0, meaning that portion is what we call the x-intercept. X-intercept, meaning this portion and this portion is our x-intercept. Remember again, this portion is our x-intercept. So how do we know that? When the value of our function becomes 0, then that is our x-intercept. Then the third one is our given is that one. What could make this function undefined? So that is when the value of our denominator becomes 0. So what value of x that could make this function undefined? That is 0. Meaning to say, this portion is undefined. That's why these two graph does not connected, is not connected because of this value at point 0 where our function is undefined. Okay, so I hope you understand in my presentation in this video about solving rational function.